Hello everyone. Today I am here to discuss on a topic that is very important in chemistry, specifically in your practical chemistry or solution chemistry. That is your preparation of a solution. So first of all, take a basic idea of what are basically we have the solution. Solution generally consists your two items. That is your solute and solvent. Solute that is present in your minor quantity and solvent is present in your major quantity, and by adding the solute in the solvent you're going to get the solution. So in the chemistry different type of solutions are used, but in term of discussion to represent their amount or amount of solute in the solution, we generally discuss or consider our two terminology, that is your molarity and normality. In addition to that, some other terminology also there, other factors are also, but these are very important, and we generally discuss in these two terminology for the solution preparation. Basic idea about the or basic definition for the molarity is the number of moles of or number of moles of the solute dissolved per liter of the solution. Means how many number of moles are dissolved in the solution, that gives us the information about the molarity, whereas normality gives us the number of gram equivalent dissolved per liter of the solution. So with this terminology, we are generally prepare our solution. Okay, so let us discuss about the preparation now. Focus toward the preparation. So for the solution preparation, the general formula for your molarity is equal to mass upon molecular mass. This mass is the required mass, so you can also write here as the required, that how many amount of mass you are going to require, and here you have the 1000 upon volume required. This is a basic formula for the preparation of your molar solution or molarity solution. Similarly, for the normal solution, the formula is remains same, mass required upon molecular mass. But in place of your molecular mass, in place of normality, here a new terminology comes, that is your equivalent mass, and this is same 1000 upon volume required. Now what is the difference between equivalent and molecular mass? There is some simple basic relation, that is your equivalent mass is equal to molecular mass upon acidity or basicity of the solute, or you can say that other sample. acidity and basicity, nothing much more difficult. It is just only the valency. You consider how many number of charges are taking place in the during the dissolution. This is the terminology. So this basic information. Now focus toward the preparation of your solution. So the preparation of solution, let's consider first of all discuss about the Molar solution. If anyone wants to prepare the Molar solution, let's consider I am going to discuss about the 1 molar solution. In the formula for this will be the 1 mole is equal to mass upon, as I have already written, molecular mass. If I am going to want to prepare the 1 molar solution of your NaOH, then I can simply going to do 1 molar is equal to mass upon molecular mass. Molecular mass of your NaOH is equal to 40. So here we have the 40 mass upon molecular mass, and here will be your 1000 upon volume required. Now, how many volume you are required of 1 molar solution? That we're going to write up here. So if I want to prepare 500 ml of solution, and I'm going to write here the 500. So from this, what I will have, this is the mass required. So from here, mass required will be 1 cross 40 into 500 divided by 1000, or you can simply have divided by 1000. So this means the amounts come to be 20 grams. That is, in order to prepare the 1 molar solution of NaOH, you have to take 20 grams of NaOH. Then in this you have to add the water, and making the total volume is equal to 500 ml. By using this simple relation, you can prepare the 1 molar solution of your NaOH. Similarly, if you are want to prepare the 0.1 molar, or you can say that 1 by 10 molar solution, 1 by 100 molar solution, or 1 by 1000 molar solution, you can prepare respectively that. So either you can prepare this, or either you are going to prepare this. By using this simple calculation, you can prepare this type of a solution. Whereas in case of your normality, their formula is little bit different, so focus to that one also, how we are going to prepare that. So if I similarly want to prepare the normal solution of your NaOH, means 1 normal solution of NaOH, same formula will be there as we have written in the previous. That means normality is equal to mass upon molecular mass. Again, here will be have the molecular mass will be same, and 1000 upon volume required. Sorry, in this case, here we have the equivalent mass, not the molecular mass, but in the case of NaOH, as only 1 ion are there, or hydroxyl ion is there, OH, so acidity or basicity in this case is 1. So therefore, its equivalent mass will be again, equivalent mass is equal to molecular mass upon acidity or basicity. So in this case, its value is 1. So its equivalent mass or equivalent weight will become equal to molecular mass. So this thing is same. So again, we are going to get the same calculation in the case of your previous work. But if I want to prepare another example on another solution in which your acidity or basicity is different, then what will be happen? For example, in the case of your oxalic acid, if you want to prepare the one normal solution of oxalic acid, for this again you will have one normal into mass required upon equivalent mass into 1000 upon volume required. So in this case of oxalic acid, as there are the two hydrogen ions that are in the molecule, so therefore acidity or basicity for your oxalic acid is 2. So equivalent weight or mass for your oxalic acid will become equal to molecular mass upon 2. So as we know that molecular mass of your oxalic acid is 90, so its equivalent mass or weight come out to be 45. So here we are going to write the 45 value, and volume required, as we have discussed in the previous case. If I am going to want to prepare the 500 ml, so I have to write as a 500. So required mass will become equal to as your previous case. Okay. So by solving this, you comes out to be just like this. So the weight comes out to be 22.5 gram. Means you have to take 22.5 gram of oxalic acid, and in this you have to add the water and making the total volume equal to 500 ml. So by using the simple relation, you can prepare the normal solution of your oxalic acid. Whereas in case of your molar solution, there will be direct molecular mass going to be used. Here. So in the case of your molar solution of your oxalic acid, if I want to discuss about that also, because I have not discussed about molar solution, but in the case of your 1 molar solution of oxalic acid, the comes out to be, here we have the 1 molar equal to mass upon molecular mass. So in the case of molar solution, the molecular mass are written. So molecular mass of oxalic acid is equal to 90. So here I am going to directly write the 90, and here will be similarly 1000 upon volume required, and required mass comes out to be 1 into 90 into 500 divided by 1000. So its weights come out to be 45 gram. So by dissolving 45 gram of oxalic acid in water and making the total volume is equal to 500 ml, you are going to prepare the 1 molar oxalic acid solution. Okay, so it's a basic discussion that I have done about the normal and molar solution. Till now, I have only discussed about your solid case. Now let's focus about your solvent molecules, or in this case, in the cases when your solute molecules are in the liquid phase.